Okay, so we're going to try to go over this next section on measuring angles. It is 1.5. I'm trying my new surface out, so we'll see how this works. Always make sure that whenever you start a paper, write your name, your full name, of course, and the date. Today is the 12th for me, and whatever period you're in. Now, our objective we're going to list is to know the precise definitions of all of these words. Okay, so I'm just going to put angles, etc., based on the undefined notions of a point, line, and a plane. So if you want to follow along, we're starting out in section 1.5, okay? And when we look, today we're going to talk about angles. An angle is a set of points consisting of two different rays that have the same end point called the vertex. Okay? The rays are the sides of the angle. So hopefully you can see this is, I wanted to do that. This is a ray, and this is a ray, but you can see this is the vertex. That's A. If more than one angle has the same vertex, okay, same vertex, the name can't be used. So, like say this said D, but there was more than one angle there. If there's any confusion, you can't use it. Okay, so here's an example on how we would name them. You can see a lighthouse keeper measures the angles formed by the lighthouse at point M and 3 boats. Name 3 angles in the diagram. So the first angle, we make our little angle symbol. It's going to be J, M, K. So you start with the outside one, you go to the vertex, and then you go to the K. The vertex must be in the middle. Okay, another angle is KML, again, vertex. And a third angle, which you may or may not be able to see here, is the big one. So it's going to be JML. So they can be overlapping, but always, the vertex is in the middle. Okay, next, if we're going to measure an angle, you see the picture of the protractor. And we have this postulate, and we have angle AOB, okay, the measure of angle AOB, which can be written with a little m and then an angle. So you say it, measure of angle AOB is equal to the difference between the real numbers matched with OA and OB. So basically what that means is you have to look right here where it's coming out. So like this is 0, and so you're going to be measuring all the way to over here. Now you can see in the picture that looks like 140 degrees. If you wanted to know the other angle from here to here, that's 40, because together they have to be 180. Now, another thing we're going to do is we're going to classify them by both their angles and their directions. So an acute angle is less than 90 degrees. You can think of it as a cute little angle, you know, like a baby's cute. Okay, a right angle is exactly 90 degrees. An obtuse angle is more than 90 degrees. And a straight angle is exactly 100. Another word for that would be a line, 180. Hopefully you've got that written down. Now, these are review concepts, I know for some of you, but what we're going to do is just trace them and then classify them with those words we just used. So find the measure and then classify. So GHK goes from 0 to H all the way up to K. So that looks like it's going between 120 and 130. And so I'm going to say that's 125. Now change colors here. So let's try JHL. So J to H is here and L is here. So that's going to be 90 degrees. And LHK, we start with L, go down to H, and then K is right here. So if you know that this one is at 125 and this one, so this one's at 125 from G, then that means that this way it is 55. And from here to here, this one's 90. Then the difference is going to be 35 degrees. So LHK is 35. Hopefully you can see that. Now for each one of these, then we're going to classify them. So this one's more than 90, which means it's obtuse. This is exactly 90, which means it's right. And this is less, so it means this is acute. Okay, now if we identify two angles are congruent when they have the same measure. The same measure. Okay, it's got to be exactly that, same measure. Okay, we're moving on. We've now moved on to page 41, the angle addition postulate. We move to go back to blue. Okay, in words, if P is in the interior, meaning the inside where the vertex comes together of RST, then the measure of RST is equal to the sum of the measures of angle RSP and angle PST. Okay, now in symbols, if we just didn't want to write all the sentence out, if P is in the we still are going to use that vocabulary word, interior of RST. Okay, interior means inside here. This is interior. Then we can write the measure of angle RST is equal to the measure of angle RSP plus the measure of angle of PST. So it's the red is RSP, the green is PST. And so that's called the angle addition postulate. Now, we're going to go on to finding some angles. So here's how we can use that. Okay, find ABC. Well, if you know ABC is equal to ABD angle plus DBC, and you're given that one is 37 degrees and the other one's 21 degrees, you're going to add those two numbers together and you're going to get 58 degrees. Secondly, if you know that from R to S to T is 114, all of this is 114, then finding RSV from here, this angle, we're going to subtract. The other one is labeled that. And so measure of angle RSV is 42 degrees. Last, L is in the interior of JKM. Find measure of angle LKM if JKL is 56.4 and JKM is 82.5. Sketch a diagram first. So I'm going to make an angle. It looks like these two added together is more than 130. So I'm going to like that. J will be over here. K must be in the middle because it is the vertex. And then somehow, let's see, or JKM is actually going to be 82.5. Hold on. That's okay. I'll just adjust. Use a pencil because it says that JKM is 82.5. So this is 82.5. And then JKL, where L is going to be in the interior. Okay, so L is somewhere in here. JKL is 56.4. So it's asking you to find L to K to M. So all of it is 82.5. And you're going to subtract 56.4. So 26.1 degrees. And hopefully we got all that down.